All right, welcome to The Explainer. Today, we're going to pull back the curtain on something that's, well, it's basically invisible, but it's one of the most important pieces of tech in our lives. I'm talking about modulation. It's the secret sauce, the magic trick that makes our entire wireless world actually work. I mean, have you ever really thought about it? That song you love, how does it actually travel miles from a radio station and just appear in your car with no wires? It seems like magic, right? But it's not. It's actually a really brilliant bit of engineering that solves a huge, fundamental problem. So let's dive in and see exactly how it works. Okay, so here's how we're going to break it down. We'll start with the problem, the impossible journey, then we'll look at the clever solution, modulation itself. We'll meet the key signals involved, see how they actually change the carrier wave, find out where you see this stuff in your world, and wrap up with a final question about the future.
All right, first up, the impossible journey. This is the big why. Why can't we just, take the sound from a microphone, turn it into an electrical signal, and just broadcast it? What's stopping us?
Well, the thing is, the original information, engineers have a name for it. They call it the baseband signal. It's not built for a long trip. It's naturally weak and low frequency. It's kind of like trying to whisper to your friend across a massive football stadium. Your voice, that signal, just isn't strong enough to make it on its own. And there are a few huge reasons this whole idea is a non-starter. First off, like that whisper, they just fade out almost immediately. Second, and this is wild, the physics of it means you need a ridiculously huge antenna. I'm talking miles long. Just not practical, right? And finally, let's say you solve those two problems. Well, now you've got a new one. Every single signal, every radio station, every phone call would just crash into each other, creating one big, useless blob of static. Total chaos.
So yeah, clearly just trying to shout our information into the void is a complete failure. We need a much smarter way to do this. And that brings us to our next section, the clever solution. It's really this ingenious piggyback trick.
And this analogy, it is absolutely perfect. It nails the core idea. Think about it. Your message, the song, the data, whatever, it's like a piece of paper. You can't throw a piece of paper very far, right? It just flutters to the ground. But what if you attach it to a brick? Suddenly, you can throw that thing a long way. The brick is the power. It's the muscle. The whole game is just figuring out how to tape that piece of paper onto the brick so it can go for a ride. And that process, taping the paper to the brick, that's what we call modulation. That's the official term for it. It's all about adding our weak message signal onto a super strong, high-frequency carrier signal so we can launch it across cities, across countries, or even from a satellite in space. Okay, so to make this whole thing work, we obviously need two key players. Let's meet them. We'll call them the message and the messenger.
So let's really break down the difference between these two. On one hand, you've got the message signal, or the baseband. It's low frequency, but it's got all the good stuff, the information. It's the what we want to send. Then you have the carrier signal. This one is high frequency, and to start with, it's totally empty. It has zero information. Its only job is to do the heavy lifting. It's the how we're going to send it. It's the letter versus the brick. Simple as that.
All right, so we get it. We need to stick the message onto the carrier. But how? How do you actually do that? That's what we're getting into next. We're going to look at how we change the carrier wave, which is basically the secret behind AM and FM radio.
So, AM and FM. You've seen these on your car radio a million times. They're kind of the two classic, original ways of doing this. For amplitude modulation, that's AM, we mess with the carrier's strength or its height. For frequency modulation, FM, we mess with its speed or its frequency. Let me show you what I mean. Okay, so for AM radio, you start with this nice, constant, predictable carrier wave, just chugging along. Then you basically take the shape of your message, your music or voice, and you stamp it onto the carrier by changing its height. So where the music is loud, the carrier wave gets taller. Where it's quiet, the wave gets shorter. The information is now encoded in the height of that wave. Now, FM is a little different. Again, you start with that same steady carrier wave. But this time, instead of changing its height, you change how fast it's oscillating. So you make the waves bunch up really close together for one part of the message, and then you make them spread way out for another part. Now, the information is encoded in the spacing or frequency of the wave. You know, all this talk of waves and frequencies might sound a bit abstract, but I promise you, this is technology you are using constantly, probably without even thinking about it. So let's bring this out of the theory and into your tech, into your world. Of course, AM/FM radio and TV are the classic examples, but it's so much bigger than that.
Your Wi-Fi router? It's modulating data like crazy right now to get this to your screen. Your smartphone? It uses super complex types of modulation to give you 4G and 5G speeds. Satellite communications, your car's remote key fob, even your garage door opener. It's just everywhere.
Okay, let's go back to our analogy. The brick with the paper tape to it has been thrown. It made the journey and it landed right where it was supposed to, in your radio or your phone. Mission accomplished, right? Well, not quite. Because you don't care about the brick. You just want the message that was on the paper. So, what happens next?
This is where the other half of the magic trick happens. It's a process called demodulation. And you guessed it, it's the exact reverse of what we did before. Your device, your receiver, is built to do one thing perfectly. Ignore the carrier wave, basically toss the brick aside, and very carefully pull off that original piece of information. It separates the message from the messenger.
And just like that, the journey is complete. The message has arrived. Which brings us to our final section, and a final question about what the future of all this looks like.
When you really boil it down, this simple idea, giving a weak signal a piggyback ride on a strong one, it's so much more than just a clever trick for old-timey radio. It is the absolute foundation of our entire modern communication network. Without modulation, wireless as we know it, well, it just wouldn't exist. Period.
So that leads us to the big question. Think about the progress. We've gone from sending a simple voice signal with AM radio to streaming 4K video over 5G networks using incredibly complex digital modulation schemes. As our world demands more and more data, faster speeds, more connections, what's next? What will that next great leap in modulation actually look like? What does the future of the signal truly hold?